Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on matrices and determinants. In today's lesson, you will learn about Kramer's rule. When you are trying to solve systems of linear equations, you can use Kramer's rule to solve for just one of the variables without having to solve the whole system. This sounds like a very useful rule. Let us begin the lesson. Students, you already know that determinants can be used to solve systems of linear equations with an equal number of equations and variables. Let us use this system as an example. A1x plus B1y equals C, and A2x plus B2y equals D. Our first step is to multiply the first equation by B2 and our second equation by B1. This gives us A1B2x plus B1B2y equals B2c, and A2B1x plus B1B2y equals B1d. Now we can subtract the second equation from the first. This results in A1B2 minus A2B1 times x equals B2c minus B1d. We can express this equation in determinant notation as follows. A1, B1, and A2, B2, and x equals C, B1, and D, B2. Let our determinant D equal A1, B1, and A2, B2, and our determinant x, or dx, equal C, B1, and D, B2. If our determinant is not equal to 0, then x equals dx over D, or C, B1, and D, B2 over A1, B1, and A2, B2. This method is called Kramer's rule. You can also use it to solve for y. Y equals dy over d. Please note, students, that in order to find the determinant for x and y, or dx and dy, we replace the first and second columns with our constant column vector. The constant column vector is the answer column. In this example, C, D. Students, it might be easier to understand Kramer's rule by using actual equations with real constants. First, you will try to solve a system of equations with only two variables. Please take down these equations and solve the system. 4x plus y equals 0, and x minus 6y equals 7. Remember that Kramer's rule states that x equals dx over d and y equals dy over d. Begin the activity now.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. How did you do? Let us go through the solution together. Our first step in solving this equation is to find the coefficient matrix, and from that, the determinant. The coefficient matrix is 4, 1, 1, -6. To evaluate the determinant, we subtract the cross products of the matrix. So, we get -24 minus 1, which is -25. This is the value of D. To find dx, we substitute the constant vector column, which in this case is 0, 7, for the x column. We get 0, 1, and 7, -6. Evaluating this determinant gives us -7. So since x equals dx over d, our answer for x is 7 over 25. We perform a similar calculation to find y. To find dy, we substitute the constant vector column 0, 7 for the y column. This gives us 4, 0, and 1, 7. Evaluating this determinant gives us 28. Since y equals dy over d, our answer for y is -28 over 25. If you answered that x equals 7 over 25 and y equals -28 over 25, you are correct. Excellent work, students. Kramer's rule is valid for any system of linear equations so long as the coefficient matrix is square, such as 2 by 2 or 3 by 3. In cases where the matrix is more than 3, the large number of calculations makes Kramer's rule impractical. In those cases, the Gaussian method we learned in the last lesson is preferred. One final statement to note about Kramer's rule is that it does not work when the determinant equals 0. Students, are you ready to solve a system of linear equations with 3 variables? Please write down and solve the following system using Kramer's rule. 2x plus 1y plus 1z equals 3 1x minus 1y minus 1z equals 0, and 1x plus 2y plus 1z equals 0. You may begin now, students.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello again, students. I am sure that you did not find that too difficult. Please check your work as we go through the answers together. Our first step is to find the determinant of the coefficient matrix and evaluate it. Do you recall how to evaluate a 3 by 3 matrix? We take the sum of the products of the down diagonals minus the sum of the products of the up diagonals. After much calculation, we find that D equals 3. Next, we substitute the answer column, or constant vector column, 3, 0, 0, for the x column to find dx. Here is the matrix for dx. If we evaluate the matrix, we find that dx equals 3. We perform the same calculations to find dy and dz. dy equals -6 and dz equals 9. Now that we have our values for d, dx, dy, and dz, we can use Kramer's rule. We solve for x with dx over d. 3 over 3 equals 1, so x equals 1. Y equals dy over d. -6 over 3 equals -2, so y equals -2. Z equals dz over z. 9 over 3 equals 3, so z equals 3. Good work, students. You have learned how to use Kramer's rule to solve systems of linear equations with 2 or 3 variables. Just remember that to solve for any variable, all you have to do is evaluate the determinant quotient. That is all the time we have for this lesson. Until next time, thank you, teacher. Thank you, students.